Hello students, chemistry is involved in our day-to-day life. Almighty has created a beautiful world in which the living organisms grow, wither and finally perish. Plants grow, milk curdles, the food we eat gets converted into simpler substances in our body. In a nutshell, we can say that there are a variety of changes occurring around us, and these changes can be both physical as well as chemical changes. Chemical changes are accompanied by chemical reactions, and these chemical reactions are represented in the form of chemical equations. So students, in the first chapter of 10th class chemistry, we will study about the variety of chemical reactions and the way of representing them in the form of chemical equations. So let us begin with the chapter Chemical Reactions and Equations. So the first chapter of 10th class chemistry is Chemical Reactions and Equations. So the chapter is Chemical Reactions and Equations. Students, before coming to the main topic, chemical reactions, let us recall about two types of changes. You have already studied in the 9th standard, there are two types of changes. So what are those two types of changes? If we see, there are two types of changes. One are physical changes and the second are chemical changes. Now let us recall what are physical changes. Now students, during a physical change, there is no new substance formed. So in this, no new substance is formed. Now students, what type of change is this physical change? Now students, during a physical change, there is just a change in the physical properties of matter, whereas the chemical properties remain the same. And these physical changes are usually reversible also. So students, in this a physical change, only the physical properties change. Physical properties change. Now students, let us understand this with the help of example. Let us see, we have water which is having formula H2O, and the state of water at room temperature is liquid. Now when we heat water, upon heating it vaporizes, that means it converts into its vapors or the gaseous state of water. So water from the liquid state gets converted into the gaseous state. Now students, what happens when we cool water? That means from the liquid state, on cooling, water gets converted into ice, which is the solid form of liquid water. Now students, these are the type of changes. Now what is happening in this change? Now you can clearly see that upon melting and upon cooling, there is no change in the chemical property of the substance. The formula of water remains H2O on both the sides. Now what is the change that is actually happening? There is just the change in the physical property of the substance. Now here, the physical property is the state of the substance. Originally, water was in the liquid state. Upon the change, it gets converted into the gaseous state. And here also you can see water from the liquid state gets converted into the solid state. Now students, so these are the physical changes in which no new substance is formed. There is just the change in the physical property of the substance. Now let us see what are chemical changes. Now students, during a chemical change, opposite to that of the physical change, there is a formation of new substances. So what happens during a chemical change? New substance is formed. Now students, as physical changes involve just the changes in the physical properties of the substance, whereas in the chemical change there is change both in the physical as well as the chemical property of the substance. So, physical as well as chemical properties change. And students, these chemical changes are generally irreversible, but we have certain reversible reactions also. So students, in the chemical change, new substances are formed. There is change both in the physical as well as the chemical property of the substance. You must be familiar with rusting of iron. What happens in the rusting of iron? Iron gets converted into rust. What are the physical colors of these substances? Iron is in silver color and rust is in brown color. So let us see what type of change is this. Now upon rusting, iron gets converted into rust. Now students, you can clearly see rust and iron both are chemically different. Now as they are chemically different, there is change in the difference in the chemical property of the substance. Now moreover, we know that iron is silver in color, rust is brown in color. So there is change in the physical properties of the substance also, which is color here. Physical property is color here. Another example, students, can be digestion of food. What happens in the digestion of food? The food we eat upon digestion gets converted into simplest substance in the body. Now the simplest substance is glucose. And students, food and glucose are chemically different. So students, this type of changes, even the curdling of milk, if we keep milk outside for a long time, it turns sour. Why is it so? It turns sour because the properties of milk change. The properties of milk change because the new substances are formed. So rusting of iron, digestion of food, curdling of milk comes under the category of chemical changes. Here it involves both the changes in the physical as well as the chemical properties of the substance. Now students, how a chemical change occurs? A chemical change occurs because of the chemical reactions. So let us know what are chemical reactions. What are chemical reactions? Students, these are simply the processes involving the chemical change. So, the process involving chemical change is called a chemical reaction. So students, it is the process involving a chemical change. Now students, in the chemical reactions, the original substances we take are known as reactants and the new substances formed are known as products. So original substances during a chemical change or during a chemical reaction, original substances are known as reactants. And upon the change, upon the reaction, these original substances gets converted into new substances and new substances are known as products. Now what actually happens during a chemical reaction? During a chemical reaction, there is the rearrangement of atoms. Let us see that with the help of example. Let us suppose we have coke and it reacts with oxygen to give you carbon dioxide. Coke reacts with oxygen to give you carbon dioxide. Now students, what is coke? This is one of the allotropic form of carbon itself. What is the allotropic form, students? Here coke is the allotropic form, or we can say a different physical form of carbon itself. So students, we are familiar with the formulas and symbols of the substances also. Let us represent them. If we have coke, that is carbon, it reacts with oxygen. Oxygen is present in the form of the molecule. It is a diatomic molecule. That means it consists of two atoms of oxygen. Next we form carbon dioxide. Now students, if I have to represent, can I represent the carbon atom in this way? This is the carbon atom. there are two atoms of oxygen which are constituting one molecule of oxygen. So the two atoms of oxygen can be represented in this way. Now students, what actually happens during a chemical reaction? There is the breakage of original bonds which are present in the reactant side and the formation of new products, new bonds in the product. So what actually happens? Here the bond between the oxygen atoms break. So students, if I show like this is the carbon atom, these are the atoms of oxygen constituting one molecule of oxygen. Upon rearrangement, upon this reaction, what will actually happen? This bond will break in the reactant side and new bonds will form. So new bond formed will be carbon in the center and oxygen atoms will form bond with the carbon atom. I hope students it is clear. So students, as this is representing carbon atom, oxygen molecule, and here is the formation of new bonds between the carbon and oxygen atoms. So this is carbon dioxide molecules. So during a chemical reaction, there is just the rearrangement of atoms. It is not like this that the atom of carbon will change into the atom of any other element. It is not like this. Now students, I hope this is clear. Now how do we come to know that whether a chemical reaction has occurred or not? This we can easily see by certain observable changes. So next we will study about certain observable changes. Students, the conversion of reactants into products is usually accompanied by certain observable changes. And these observable changes are known as the characteristics of chemical reactions. So let us study the characteristics of chemical reactions. Characteristics of chemical reactions. Students, during a chemical reaction there are many observable changes. These changes can be change in the state of the substance, change in the color of the substance, evolution of gas, formation of precipitate, or changes in temperature. So let us study these observable changes or the characteristics one by one. First of all, let us study there can be change in state of substance also. Change in state is also observed during a chemical reaction. Let us see now students, when hydrogen reacts with oxygen, it gives us water. We all know this. So when hydrogen reacts with oxygen, it gives water. Now students, what about the physical states of the reactants and products? Hydrogen and oxygen are reactants, so these are the reactants, and water formed is the product. Now students, we know that hydrogen is a gas, so yes, it is in the gaseous state. What about oxygen? Oxygen is also a gas, so this is in the gaseous states. Now what about the product, water, which is formed? Now water formed is in the liquid state. So students, this reaction if has occurred, that means if hydrogen has reacted with oxygen, there will be a change in the state of the product. So by the change in the state, we can easily see that whether the reaction has occurred or not. Second students, there can be change in the color of the substance also. So second observable change can be change in color. Students, let us take a daily life example. We must have seen tarnishing of silver, rusting of iron. So what actually happens? In these, a chemical reaction occurs. New substance is formed. How do we see that whether iron has reacted with atmospheric oxygen, water vapors to form rust? Now students, first example can be rusting of iron. We know during rusting of iron there is change in the color. Iron is silvery or blackish in color and the rust formed is brown in color. So during the rusting of iron there is change in the color, so we can easily guess that whether the reaction has occurred or not. Second can be tarnishing of silver. tarnishing of silver. Now students, what is tarnishing of silver? This is actually the corrosion of silver. Silver is silvery in color and the tarnished silver is black in color. So students, when the color of silver changes into black color, that means we guess that it has tarnished or a chemical reaction has occurred. So students, by this way, by the change in the state, by the change in the color, we can easily guess that whether a chemical reaction has occurred or not. Now third observable change can be the formation of precipitate. Formation of precipitate. Now students, precipitate is a solid residue which is formed at the bottom of the reaction mixture. Now students, let us see with the help of the example of a reaction. Now students, if we have a reaction between potassium iodide, so we have a reaction between potassium iodide and we have lead nitrate. Now students, when potassium iodide reacts with lead nitrate, it gives potassium nitrate and lead iodide. Now students, in this reaction we see then when potassium iodide reacts with lead nitrate, it gives us potassium nitrate and lead iodide is formed. Now students, this lead iodide is actually observed as a solid residue at the bottom of the beaker. Now students, this solid residue is also known as precipitate, or simply in the short form it is written like this. Now students, when the precipitate of lead iodide has been formed, we can easily guess that whether the reaction has occurred or not. Now students, during a chemical reaction there can be one or more observable changes. If we see the example of this reaction, in this reaction we can see that there is formation of precipitate, so we can guess by the formation of precipitate also. And moreover students, the reactants in this potassium iodide and lead nitrate are colorless, and the product, which is lead iodide formed, is yellow in color. So students, you can easily see that when the colorless reactants will change into yellow colored product, that means the reaction has taken place. So students, these were the three observable changes. Next we have two more observable changes, or the characteristics of chemical reactions. Students, the fourth observable change can be evolution of gas. Evolution of gas can also tell us that whether the reaction has occurred or not. Students, in the previous classes you have studied the example of a reaction, which is the reaction between zinc and dilute acids. So students, when zinc reacts with dilute acids, here dilute acid I can take is dilute hydrochloric acid, this reaction, it evolves hydrogen gas. Now students, in this reaction there is evolution of hydrogen gas, and if the hydrogen gas has evolved, that means this reaction has taken place. Now students, how do we come to know that hydrogen gas is evolved? We can easily see this as hydrogen burns with a pop sound. Now students, what actually happens when zinc reacts with dilute hydrochloric acid? It forms zinc chloride and hydrogen gas is evolved. So in this, when evolution of gas takes place, we can easily see that the reaction has taken place. Now students, fifth observable change can be change in temperature. Students, the chemical reactions are generally accompanied by changes in the temperature. Why is it so? Students, to break a bond between the reactants or in the reactants, energy is required. And during the formation of new bonds in the product side, energy is released. And these two energies, the energy absorption and energy which is released, are generally not equal. So there can be rise in temperature also or fall in temperature also. So there can be two categories in changes in temperature. There can be rise in temperature Students, rises in temperature is when heat is evolved. And students, when heat is evolved, those reactions in which heat is evolved are known as exothermic reactions. So students, there can be rise in temperature. We can easily see the rise in temperature by touching the beaker. If it turns warm, that means there is rise in temperature and the chemical reaction has taken place. So students, in which the heat is evolved, those reactions are known as exothermic reactions. Let us see an example. If we have quicklime and react it with water, it gives us slaked lime. And students, when we touch the bottom of the beaker, it turns warm. That means if the reaction between quicklime and water has taken place, then the beaker will turn warm because of the formation of slaked lime and the evolution of heat. So students, moreover we know that the chemical formula of quicklime is calcium oxide. It reacts with water to give you slaked lime, which is having chemical formula calcium, which is calcium hydroxide. So students, if the reaction has taken place, there will be rise in temperature. Second, there can be fall in temperature also. So second can be fall in temperature. Students, fall in temperature occurs when heat is absorbed. And students, the reaction in which the heat is absorbed, that means in this reaction more amount of energy is required to break the bonds in the reactants than the energy released in the formation of new bonds in the product side. So in this, when the heat is absorbed, these reactions are known as endothermic. Endothermic reactions. Students, well-known example of this reaction in which fall in temperature is observed is the reaction between barium hydroxide and ammonium chloride. Now students, when the reaction between barium hydroxide and ammonium chloride occurs, there is the formation of barium chloride, ammonia, NH3 and water. And students, when we mix the two reactants, ammonium chloride and barium hydroxide, in a test tube and stir them and touch the bottom of the test tube, we will see that it turns cool. So that means there is fall in temperature during this reaction, and this fall in temperature easily tells us that the reaction has taken place. So students, coming back, there can be 5 observable changes. Students, as you can see that there is change in the state of the substance also during a chemical reaction. There can be change in color. There can be formation of precipitate, evolution of gas or change in temperature. Now students, in a chemical reaction, there can be one or more observable changes. If we see this reaction of zinc with dilute acids, here is the evolution of hydrogen gas also, and moreover students, in this we also see that there is change in temperature also. Temperature rises during the reaction. So students, these were about the characteristics of chemical reactions. We know that there are various types of chemical reactions. Before studying the various types of chemical reactions, next we will study the way of representing these chemical reactions in the form of chemical equations.